A very warm welcome to this webinar on the introduction of big data, a bit about HDFS architecture, and then a very interesting topic called TDD, or sometimes we call it as test-driven development using pig unit. Or rather than that, I would give it a more generalized term called test-driven development in big data world altogether. So we'll be seeing those aspects. But before I proceed forward, since last time when I just did a sound check till now, I think almost some 20 more people have joined in last 2-3 minutes. So I'm sure that all of you should be able to hear me still. But just in case, can we just do a quick sound check with others as well? You can just say yes, no, sort of, if you are able to. Thank you, guys. Thanks a lot for confirming. Hi, Riju. Hi, everybody. So yes, we are already having, I think, almost some 70 people right now, and it is just increasing by every passing minute. So let others to join, but again, since 1 hour to cover some specific topics in depth is, of course, not enough. But still, we would, what we decided is we'll be focusing on some of the aspects, and whatever time we are going to spend on the topics, that should be like, basically there should be some value out of this 1 hour. So every minute is precious for us. Let's get started quickly and let others to join by the time, others are going to join us. So let me just quickly get started, guys. So hi, as I just told some time back, my name is Vishal, full name Vishal Kumar, and I'm having almost more than 12 years of overall industrial experience and working in big data domain since last almost 5 years. From the different domains perspective, I have the exposure towards the retail domain and the finance domain primarily. There were a bit of projects which we did for telecom as well as healthcare domain. But again, that was significantly, it is in the retail and the banking domain altogether. When I talk about my experience in big data world, so I'm not really saying it is Hadoop, it is big data world. And when I talk about it, it started with Hadoop, as it happens for many people. And now my specialization is towards the kind of, Lambda architecture implementation, wherein it is not just the Hadoop thing, it is the coexistence of Hadoop systems with either your enterprise systems, or it is the coexistence of Hadoop batch analytics along with some of your near real-time kind of applications, for example, Spark or Storm and all. But yeah, that's a different league, and so that's how the evolution has happened. Have worked with major teams and have been a part of quite intensive, or I would say big data intensive teams in Sears Holdings, Citigroup, and then there are some other clients for which I have worked. And apart from that, I just have one specific passion, due to which, you all are here and you are all listening to me. I love sharing the information. I love sharing, the knowledge of Hadoop, the interesting insights which we found, and how exactly we can use them at the enterprise level. So I think that's pretty much about myself. Let's not, go further on it. We'll anyway be able to discover more as and when we'll be continuing with our, classes as well. So just going forward, before I proceed, seems like Naveen is not able to hear, but I am sure others are. So let me just reply to Naveen. Probably he can just rejoin. Please rejoin. Others are able to hear. So sometimes there might be some of the, individual end problems wherein there might be some of the bandwidth issues and all. At that particular time, I typically suggest you can just drop a message whether you are able to hear or not, and we can do a quick, check. Probably in that case, you can just try to rejoin. That really helps. Okay. Now, I'll quickly come to the objectives which we have in mind, or the things which we would really love to discuss in a bit more details in this almost 1 hour duration. It's about learning of big data and Hadoop. So when it comes to the term of big data or Hadoop, they have almost become kind of a jargons in industry now. Almost each and every company is talking about it. Whether they are working on it or not, it's a separate question, right? But almost everybody is talking about it. And then what really is kind of so much exciting about this big data and Hadoop kind of world? What makes it so challenging, and at the same time what makes it so exciting and one of the highest paying domains altogether? So those are some of the things, right? We'll try to demystify some of the common myths in this part. But again, at a very high level, because when it comes to the actual course, there is a separate session of almost 3 hours, which is only on this part. And then we will quickly, again, at a very high level, we are going to look at HDFS, that is called Hadoop Distributed File System. It is one of the core components of Hadoop ecosystem itself. You will see that very quickly when I will be talking about Hadoop ecosystem itself. But yes, we'll just try to see at least what exactly are the different components of HDFS, right? It's of course not possible to cover all of that, the intricacies of each and every part, but at least you should be having some idea, what exactly separates Hadoop distributed file system from a normal file system, right? So if we are able to achieve that, it's a good achievement, seeing the kind of duration. And last but not the least, not really sure, I would like to take a very quick poll of the class. How many of you have heard the term, or rather than saying that, have practiced the test-driven development? So when I talk about it, it need not to be in the big data world or in your, let's say, any project, but it could be in web development area, it could be even in a migration project, it could be in any of these things. Exactly. So this would just give me a, effectively I'm doing a sampling of my people here. So could you just say yes or no, kind of? That would help. And by the way, this is the kind of interaction which we follow as well in the class. So, okay. So I think apart from 1 or 2 yes, most of the things are no. So I'm sure then this is going to be quite an interesting thing for the people who would not have heard about it, or I'm not really sure even those people who are saying that yes, whether you are practicing it or not. So hearing it is one thing, and then practicing it is completely another thing. So that would be one. And then last but not the least, I'll be having a very quick, some of the things which are specific about Skillspeed, what exactly are the things which make Skillspeed offerings different from others and other stuff. So I'll be quickly talking about that. But again, the focus is completely on the knowledge sharing part, and that part would be at the last. So let me just quickly get started with the things. And of course, guys, even though the duration is 1 hour, the focus is on getting the things clear, and then even if we are, let's say, overflowing by 5 or 10 minutes, I hope you won't mind it, because it is all about the quality which we are going to deliver. Okay, so let's quickly talk about big data and its challenges, right? Before even we start on it, just have a look, not of the text. This is a kind of a funny caricature which you are seeing on the left hand side of your screen. So how's the big data project coming along? And then you are not even able to see the person, right? So not really sure how many of you have seen these kind of situations actually happening in the industry itself. So okay, let's not focus much about this caricature. Let's come to some serious stuff. And then I'm just going to ask this question to all of you. For some time, just don't look at the screen. You can close your eyes and in fact, just think, what do you understand by big data? I'm sure the moment you talk about what is big data, there must be several, kind of definitions which come. There must be several, that 3V characteristics, 4V characteristics, and some standard definitions, or probably, I'm not really sure, there are several, organization specific definitions also have come up. But just, if we just look at the term at the very basic, it simply means very huge amount of data. Okay, as simple as that. Now, what is the definition of huge? You have just said that huge amount of data. It's very abstract and very unclear kind of a definition, right? So guys, let me just tell you a bit about it, and then, so the idea here is whatever discussions I'm doing, I'm just trying to demystify some of the basic concepts, whatever we have, right? So some years back, let's say some 4 or 5 years back, at least those senior people who are having, let's say, more than this much years of experience would easily recognize that if people used to say that your database file size, right? Those people who have worked in database side and all, they would know that if your database file size used to be in, let's say, several GBs order, 5 GB, 10 GB sort of, if it used to be in that order, your database administrators used to tell you that, guys, just be a bit more careful in the handling of it, take the proper backups and all, because you are dealing with a very large data instance, or in other words, a big data instance altogether. Okay, so the point is, some years back, the scale which we used to talk about for or the qualifying threshold, lower threshold, used to be several GBs. Okay, now that scale has tilted to late GBs to early terabytes. So I'm not really talking about the companies like Facebook, Google, LinkedIn and all. Of course, they are talking at the scale of petabytes and all. But if you look at the tier 2 kind of companies, take any bank, any retailer, etc. So they typically are dealing with several hundreds of GBs of data to early terabytes kind of data, right? So today, if you talk about it, you are typically talking about the data volume of several terabytes, or early terabytes, or several GBs and all. If you are dealing with this much amount of volume of data, then you are dealing with a big data kind of instance, big data kind of problems also. Okay, so what is such a big fuss about it, right? We are talking about huge volume of the data. What exactly, so what is the big deal about this huge volume of the data, right? So the problem, when you talk about such a high volume, it comes up with its own unique challenges, right? So I'm not literally reading this slide because I'm actually explaining all of these basic things. Now, talk about your traditional systems. Typically, how do you generally write your program, by the way? How do you generally write your program? You typically write a program, compile it in a machine, and then you supply some data to it, and then you generate the output, right? So your assumption is that you are writing a program, you're supplying the data to the program, and then you are generating the output. In all of this, your assumption is that most of the things are there in the very same machine altogether, right? But when you talk about, let's say, several terabytes, 10 terabytes, 20 terabytes kind of data, can this much data be stored in a single machine? Of course not. Typically your laptops and other stuff are going to have 500 GB, or the newer ones might have several terabytes, 1 to 2 terabytes kind of storage, but not more than that, right? In fact, even the bigger servers also, more than 5-10 terabytes becomes very, very, very difficult. So the first thing itself is, you are saying you are no longer able to store your data in a single machine. And that's where all the can of worms is opened. That's where all of your problems get started. Because The moment you talk about I cannot store my data in a single machine, you are immediately you are talking about the distributed storage. You are going to store your data across multiple machines, right? So now your scenario has changed. You are no more having the data in a single kind of a server, in a single kind of a machine. It is available in multiple machines. And the moment you talk about that you have the data which is going to be stored in multiple machines, then the immediate next thing comes up. Why are you going to have the data? Because you want to process it. So now that your data is distributed, can your normal algorithms through which you use to process the data, can they work? Of course not. Because now the moment you have distributed your data across machines, you are now going in the direction of distributed computing altogether, right? Because now your resources, when I say resources, read it as data, okay? So your data is now available across machines. So your program, whatever you used to run earlier, it has to modify it in such a way that it is going to run across different machines, get the output from all the different machines, and then kind of consolidate it, right? Now it is very easier said than done, because now saying a program is going to run on multiple machines. So what exactly is going to be your data distribution logic? Can you just randomly distribute your data across different machines? Okay, should there be a scheme? Now the moment you're talking about different machines, what if one of the machines is kind of down? Somebody came and just plugged out the network cable. What would happen in that case? So your program, if that failed on one of the machines, but let's say it passed on remaining 9 machines. Let's say you are having a cluster of 10 machines, and then 9 machines your program got successful, 1 machine it failed. What should be the decision point? Should you restart the process? Should you just go ahead with the partial results? And how would you monitor it, right? So all of these things then make your life completely difficult. So it is not just the storage part, it is, we are talking about even from the analysis perspective, even from the perspective of, let's say, visualization perspective, even from the perspective of searching of the data itself, all of these things become difficult because all of them are driven by huge volume of the data. So now with this, I will, just a sec. Yep. So with this, before I tell who generates the big data, I think I don't even need to tell you Google, LinkedIn and all. They are the usual suspects anyway. But then there are some very unusual examples which can be given. But before I go to that part, is the understanding of big data, the scale of it, and then the challenges which come along with it, are they clear to you guys? Can I get a quick check from all of you? Right? How is distributed network working? So Vinayak and others, yes, your individual questions are there. I would definitely love to do that, but having almost 100 people right now, it becomes a bit difficult. I will just try to see if I can club some of the questions at the end of the this webinar. Does it help, Vinay and others as well? Okay. So now let me just continue on the so who generates the big data? Again, these are the usual suspects which you can always see. But guys, even before coming who generates it and other stuff, let me just talk a bit more about the aspects. There are some other aspects. So these are the various areas in which big data posed the problems. But what are those kind of characteristics which are or what exactly are your pain points which will come along with big data? And in that process you will easily understand who generates big data also. So guys, one thing we immediately talked about, that huge volume. Do I need to explain anything about huge volume? I think everybody knows we are talking about several terabytes of data and all. But guys, look at some of the examples. Facebook. Look at the example of LinkedIn, or even, yeah, I think these two examples should be quite good for this webinar. So almost all of you would be having the accounts in them, and as soon as you, let's say, post something, depending upon how big is your network and all, you post some photo or let's say, some video and all, everybody starts pouring in their comments or their likes and things like that, right? And probably further shares and other stuff. Even in LinkedIn also, the moment, let's say, you join somebody joins your network, you immediately start getting some of the recommendations and all of these things, right? So if you talk about it, there is one specific thing, right? There is one specific thing which is going on here. It is not just a huge volume of the data, the time in which you have to react, the time in which you have to kind of, do something about it. So let's say I joined one of you people in LinkedIn, it should give me, or LinkedIn starts giving me some of the similar kind of connections or the people you may know of kind of a feature, right? It has to happen quickly. So we are talking about not just the volume, we are talking about the rate at which either we are collecting the data or we are supposed to process the data as well, right? We are not just talking about the volume, can I say that we are talking about the velocity part as well? When I talk about velocity, it is not just the processing velocity, guys. So I want to, make sure that you guys understand the true meaning of velocity. Velocity doesn't really mean the velocity of processing. It also means the velocity of capturing the data. So talk about it. Facebook every day captures several petabytes of data. Okay, everybody posting their Facebook updates, I just got up this X, Y, Z, and photos and selfies and whatnot, right? And then there are billions of users, right? I think more than a billion users are already active, sort of, in Facebook, right? So think about it. Forget about processing part, just capturing that data itself. The rate at which you are capturing the data itself is called the velocity part. So your velocity is also going to be very high. Now, the third aspect, which is even more important, that is, okay, so let's take the example of a bank, and then let's take the example of Facebook or something else, okay? So talk about any world level bank, like Citi or HSBC or something like that, which are having worldwide transactions and all. So what really happens in that case? They are also, so when, let's say, you talk about banks and all, you are having huge volume of data and you are capturing that. Good, yes, you are capturing it, but remember, where are you storing your data? Typically, most of the banks and other stuff, they are going to store their data in RDBMS systems, right? Oracle is the most trusted partner for others, but anyway, depending upon whatever RDBMS they choose, they are going to store it. So the moment you talk about you are going to store it in any sort of RDBMS, you are applying a structure to the data. You are applying a schema to the data, and then you are storing it, right? So you are forcing a structure on the data, and that becomes your structured data. You know how does your data look like. But talk about Facebook. Facebook is taking all kind of comments. Now, the kind of data can never be, a kind of a structured data for Facebook, because talk about your comments, whatever you put, talk about the kind of photo which you uploaded, talk about the video which you uploaded, right? So all of that data is going to be unstructured, right? All of that data is going to be unstructured data completely, right? So this is the third part, which talks about the variety of the data, right? So first part was the volume, self-explanatory. Second part was the velocity. When I talk about velocity, I'm necessarily talking about the rate at which you are actually capturing at least the records and or the data. And then the third part, which is even more important, is the variety. audio, video, free format text, formatted text, or XML file, or JSON file, or whatnot, right? So these are all, or probably if you are very lucky, even the structured data as well, right? So we are talking about various varieties of data which also come along with it, right? So these are the three things when they combine, and these three things we typically call them as 3V of big data, 3V characteristics of big data as well. Okay, I hope now it makes perfect sense. Okay, so now I'll just continue and we'll move to the next part. So now, before I proceed about Hadoop and other stuff and then positioning about Hadoop, what exactly are the kind of problems which Hadoop can solve for you, I hope the understanding of big data, the kind of challenges which come along with it, and the kind of sources which are the usual sources of big data, I think this part should be quite clear to almost all of you, right? Guys, am I right in assuming so? Can I just get a confirmation sort of? So is big data only applicable for unstructured data? No, not really. Big data, I just said that mostly you will be getting unstructured data. You can get semi-structured data like XML file or JSON, or if you are lucky, you might get some sort of data like, an export of an RDBMS table as well, Prince. Okay. So why I answered Prince's question, because it's like, that was a common question with many people. Now, let me just continue further. So now, when it comes, so these were the challenges. Now, how exactly Hadoop is gonna solve the problems for you? So before that, let's first talk about. I will first talk about what exactly Hadoop is, and then I'll tell you what exactly are the kind of problems which Hadoop can solve for you. Okay. So now, when it comes to Hadoop, so then there is a question, what is Hadoop, right? Believe me, when I ask this question in the interviews to people, and when they don't give me the right answer, probably those interviews are much easier for me. I don't have to ask much, but people give some funny and sometimes very innovative answers as well. Some people say that it is a tool. Some people say it's a database. Some people say it's a language. It is none of them. Guys, this should be, if not anything, then at least this should be the key takeaway from this session. Sorry, I just have to go back. Yep. So that Hadoop is actually a framework. Okay. Hadoop is a framework. Now, so what do you really mean by, what is wrong? Okay. So what do you really mean by a framework, right? What are some of the examples of framework, by the way? You must be coming from the different diverse backgrounds, right? So for example, struts is a framework, Hibernate is a framework, right? Ruby on Rails is a framework, right? Spring is a framework, right? So why are you calling them as a framework, by the way? Because, for example, take Ruby on Rails. What does Ruby on Rails do? It allows you to do the web development very fast. Okay, and in that process, what does it do? It provides you various kinds of utilities, and all you have to do is follow some sort of conventions. Okay, so follow some sort of conventions and let the framework do the things for you. So for example, in Ruby on Rails, if you just follow the conventions of your, creating your scaffolding and all, then all of your model layer, view layer, and controller layer is created automatically by itself. You just follow some of the conventions, all of your database table creation scripts and other stuff is created by the framework itself. So you didn't do anything. You just followed some of the conventions, and then you just focus about, the business logic of the controller, the business logic, whatever you are going to write in model and things like that, right? But remaining all the peripheral things are done by the framework itself. And that's how we define any framework, right? Hadoop is no different. Hadoop is a framework. Now, what does it do? It's a very nice one-liner sort of definition, but it has many keywords in it. Okay, so Hadoop is the framework which is going to allow you to do the distributed processing. Okay, so Hadoop is allowing you to do the distributed processing and of the large data sets. Of course, why are you going for the distributed processing? Because you are having huge amount of data, right? So it is going to allow you the distributed processing of the large data set across cluster of commodity computers. Right now assume across the cluster of different machines, right? Those machines can be like your laptops. Okay, so I'll talk about commodity computer very soon, but for now let's say your laptops, right? So you just assemble some 10 laptops together, connected them through LAN, and then that becomes your cluster, right? So it is a framework which is allowing you to process your data in a distributed fashion across the cluster of machines using a simple programming model. Wow, a simple programming model seems like a very confusing term as of now, right? So guys, when I talk about simple programming model, it's a different paradigm, and that is called MapReduce. Okay, using a method, using a way of solving the problems. Okay, so typically if I ask what is MapReduce, some people say it's again various innovative answers, but MapReduce is a paradigm. Okay, so now these are some of the keywords. I'm going to explain them one by one. First, let me say what exactly the paradigm is. So for example, if let's say I have a file, right, which is having a lot of names, and I just want to know the names which are starting with A, the names which are starting with B, and so on and so forth, basically a group by count, then if I throw this problem open to two people, one person who comes from the Java programming background, the other person who comes, let's say, from the background of SQL and all. Now this SQL guy most likely is about to think, I will load this particular file somewhere, I will create a table, I will load this data into that table, and then I'll simply fire a query and we'll get a result. Am I right? Am I right in thinking that way if I'm coming from the SQL background? Now on the other hand, the Java guy is gonna think in a completely different fashion. He or she will think that, okay, this is a file, probably I'm going to load it. I'm going to load it in a kind of a hash map or in a list or whatever, right? And then I'm gonna iterate that list, and then whatever is the business logic I'll apply, and then with system.out.println or whatever, I'm going to write it in a file operation or something. I'm going to write the results into a file, and then I'm done, right? That's the typical approach of this is how a typical Java programmer gonna think. Am I right, guys? The problem was same, the input data was same, but those two people thought completely, in a completely two different ways, and both of them solved the very same problem. And this is what I mean by paradigm. This is what I mean by paradigm. So one is the SQL type of paradigm, another is a Java kind of a paradigm, or rather than that, declarative kind of a paradigm, and then a procedural kind of a paradigm, right? MapReduce is another paradigm. MapReduce is another way of solving problem, wherein you think only and only in the form of keys and values. Is that clear? Guys, this is the best way, I could explain about MapReduce. It's a paradigm altogether. It's a way of solving the problems. Okay, so now commodity computers was the other part. So commodity computers is like your laptop. It is actually a commodity computer. Okay, so when I talk about it, say the cost of your laptop must be how much? Some 30,000, 50,000, 60,000. But talk about an IBM server or something like that, right? The cost would be in several lakhs starting, right? So they are industry grade hardware. Whereas commodity computers are like, the typical, common kind of hardware wherein the failure rate is high. So now with all those small parts, I will redefine Hadoop. Okay, so Hadoop essentially is a framework which is allowing you to process your data in the distributed fashion in the cluster of normal, commodity machines altogether using MapReduce, programming model. Is that part clear now? Is the definition making sense now? Right? So this is one level, and then how exactly it is practiced, right? So MapReduce, using MapReduce paradigm model or programming model, you are going to solve the problems basically using Hadoop. So now with this, the other important part for Hadoop is it is actually the open source kind of a platform. So all of you can actually have the access to the source code of Hadoop, and you can actually even manipulate it also. In fact, we do quite a lot for ourselves, but yes. Now, with this, I will just quickly come. It is not possible to go into the depth of each and every feature right now, but at a very high level, see Hadoop. Some of these parts would be quite clear to you by now. So you are talking about the economical part, right? You are talking about the commodity computers. Of course, you are much more economical as compared to the industry grade hardware. That is point one. Second, it is scalable because you are talking about the cluster of machines. Tomorrow you need more processing power, add more machines, you are having more power. Now, it is very much flexible as well. So when I talk about flexible, see Apache framework, basically Hadoop framework is going to allow you to do the processing of structured data, unstructured data, and semi-structured data, any kind of this thing. It is quite flexible that way. Last but not the least, it is reliability part, okay? So Hadoop is quite reliable as well. Now when I talk about reliable, so it is, guys, I just talked about commodity hardware, right? So with the commodity hardware, failure is something which is not an exception. I repeat myself. Failure is not an exception. Failure is always expected in Hadoop, okay? The good thing is, how do you come out of that failure? Basically, I'm talking about the fault tolerance part and failure recovery part. Those kind of characteristics are inbuilt in Hadoop. So we were just talking about some of the things, some of the scenario that you created a cluster, somebody just plugged out the network cable. What will happen if your calculation was running on that machine, right? How do you recover, right? So all of these things, if there is no framework, then you are the one who is going to write the programs for it. You are the one who is going to put your mind to recover those things. But the frameworks, Apache Hadoop being a framework, takes care of these things for you automatically. You don't really, it is none of your concern basically, that how does it come out of it, right? Guys, I hope it is giving you some sort of idea, right? Okay, now this is where I will give you a very brief introduction about Hadoop ecosystem. Again, it is a kind of a 10,000 feet view, but yes, this is gonna put the outline of our course also. So this is where I can actually create some mapping, how exactly we are going to even spend the time in the course also. But yes, in between there was a very kind of a popular question, which is like, what exactly is NoSQL? So guys, again, it's a completely different part. I will answer that very soon when I'll talk about the Hadoop ecosystem. You will get a quick answer about it. Okay. So quickly coming to Hadoop ecosystem, this is how your ecosystem, as it says, right? It's a framework. It is going to provide you multiple utilities to do various things. So guys, there are two core components of this ecosystem of Hadoop ecosystem. That is going to be your HDFS, that is Hadoop Distributed File System, and then the MapReduce framework. So when it comes to HDFS, it is your storage layer. All of your data, all of your files, be it structured, non-structured, semi-structured, everything is going to be stored in the HDFS. MapReduce, on the other hand, as I told you, it's a computation framework, right? So these are the two utilities. For storage, HDFS. The peculiar thing about HDFS is, I think I am going to cover that, but it's a distributed file storage. It is not like, so typically if you go to your laptop, you say, I want to open file 1 which is in the directory 1. You are sure that this particular file and directory is on your laptop and not on somebody else's laptop, right? So, but in the distributed file system, you are not really sure of it. I'll explain a bit more about it, but for now, just understand this is a storage component. MapReduce framework is, as I just told you, it's a paradigm. It allows you to, it just wants you to write your programs in the key and value fashion, and then spawning them across multiple machines, getting the results, rescheduling the failures, everything is taken care by the framework itself. For now, just ignore yarn and then yarn frameworks. I'll quickly come to that. Then you have Hive and Pigletin, which are the wrappers. You can see that they are the wrappers on the top of MapReduce. Basically, it's not very easy to write MapReduce program for the non-Java people. Then like there are various people who come from the SQL background, or let's say from the data flow languages kind of a background. For them, Hive and Pig-Latin are the wrappers. So Hive is like your SQL kind of a wrapper, wherein typically those business analysts and all, they write their queries and other stuff, and then internally all of your queries, or even in the Pig scripts, all of your data flow scripts get converted to the sequence of MapReduce job that in turn processes the data in HDFS. Okay, so it is typically aimed for the people who are not from Java background, but and don't want to learn Java only for this part, but at the same time they want to leverage the power of Hadoop. So typically those kind of people use either Hive and Peg, and then they leverage the power of it. Now, HBase. HBase is the guy which is, so I was saying about NoSQL. HBase is actually the NoSQL database of Hadoop. And when I talk about NoSQL, basically it actually means not only SQL, but here for all practical purposes, your typical SQL syntax does not work here. Here, basically, if you want to access the data, it is going to be completely in the Java API form and other stuff. But yes, it's a completely different animal. And only thing is, it doesn't need any MapReduce to access HDFS data. It accesses it directly. Okay, it accesses it directly. So it's kind of a real-time database of Hadoop. More on that when we'll move to those courses. But yes, now Yarn. So guys, Yarn is something which is the improvement in the latest version of Hadoop. What has really happened is with the latest versions of Hadoop, they have just separated the resource management into a separate layer that is called Yarn. Okay, and then there are, with this, what really has happened is MapReduce now earlier was doing the computation as well as resource management, but now since it is only the computation model and your resource management is separate, there are other Yarn frameworks like Jira, then there is something called Storm, then there is something called Spark, and a lot of other things which now can access the data of HDFS directly. So this becomes extremely useful, but again, it is for all practical purposes, it is kind of out of scope till now, because it is like until unless you are actually going to learn about Scala, Storm, and Spark part, this you are probably not going to utilize them. Okay, and then on the top of it, you are having a workflow layer, which is kind of a Apache Uzi layer. Okay, so Apache Uzi is kind of you have multiple, so you might be writing some of the Hive scripts, Pig scripts, MapReduce, etc., and then you would like to schedule the job. So Apache Uzi is the one which is kind of your scheduler for your ecosystem. So as you can see that it is the ecosystem which is providing you various utilities to do various things. That's why we are calling Hadoop as the framework, right? So with this, I'll move to the next part. That is about HDFS. Okay, so with HDFS, let me so I think I've already given the idea about it. HDFS is actually the distributed file system. It is the storage layer for you. And the good thing is, since I said it's a distributed thing, I just gave a quick example some time back that when you are, let's say, saving your particular file, or you are going to open a particular file from a system, then you are sure that you are accessing it from a machine 1 or machine 2. But from the distributed file system, all you will say is, I need a file 1 from directory 1. Now, where exactly that file is, that file might be, let's say, some 200 terabyte file. Now 200 terabyte file definitely cannot be in a single machine. It has to be in multiple machines. So from where exactly you have to fetch the data, how you have to fetch the data, all of that is taken care by HDFS. For you, it is Hadoop FS-cat and then whatever, directory / something, and then you start getting the data. That's the main advantage of HDFS. Okay, it typically has two kind of nodes in it. One is the master, that is called name node, and then there are a lot of data nodes itself, which are the actual workhorses. So your data nodes are the ones which are responsible for having actual data, and the name node is just the master. So it's like any operation which has to happen with the data node has to happen via name node. Okay, so name node is the master for all of the all the practical purposes. Okay, so with this I will quickly just summarize all of the things, and that will lead to another interesting discussion. Okay, so with this you can actually see that, you know, these gray color boxes are nothing but the different machines of your cluster. And then so data block, basically, so block right now you can assume is the smallest unit of the data which can be stored. It's not really possible to get into the depth of data blocks right now because it's like a different discussion itself, but for that all practical purpose you can just think that it is just the data which is stored across different machines. Now any client who has to write the data will first, you know, contact the name node, and name node, since it is the master, it does not have any data, it just keeps all the metadata of it. When I talk about metadata, it is like this file number 1 is present on machine number 2 and 3, file number 2 is also present on machine number 2, 3 and 4, right, and things like that. So all of that information is there in with the name node. Or for example, these are the different machines which are free right now. So whenever you have to create a new file, you can just create on these so and so machines altogether, right? So all of this information is there with the name node, and any client operation, be it the read operation or the write operation, first talks to the name node. Name node then gives the appropriate machine locations to the client, and then client in turn talks to those specific, you know, machines. So right now, if you are, you know, finding it a bit more detailed, don't worry, because there is a lot of basic things which will be discussed in the classes. Right now it is all about just to give you the idea from the schematic perspective. Okay, so then client is gonna talk to each and every machine itself, and that's where, you know, this interfacing happens. So client, when it was talking, it didn't know anything about which machine it has to go. Name node is the one which is the kind of a director right now. It's kind of an index as well, like Ram Kumar just mentioned, but not really just the index. Okay, so this slide just quickly talks about the kind of data which you can keep in memory, and it is, we just talked about that, yes, it is the metadata. Guys, only thing which is, I would say, is the call out of this slide is, just a sec, is that all of this data has to be in the main memory of the name node. This data has to be in the main memory because you cannot really fetch this data again and again from the hard disk and serve so many clients, right? Now, the moment you are talking about that you are having a name node which is the master, you are also saying that you are having a single point of failure. Okay, single point of failure, because if the name node goes down, then you do not, you know, you cannot practically do anything, right? So Hadoop provides you a way of taking the backup that is called the secondary name node, wherein you basically it keeps on taking the backup of name node every 1 hour about their metadata. It just keeps that stored. So whenever there is a failure of the name node, you are always going to start your secondary name node to take the backup, to load whatever metadata it has backed up into the memory, and then you know, your operations get working. So these are just the components for now. Just treat them as the placeholders. There is a lot of discussion which goes about, you know, so when it comes to secondary name node, how exactly it will take the backup, what will happen if I take the backup 10 o'clock and the failure happens at 10:15, what about that 15 minutes data and other stuff, right? So for now, just ignore that part, because of course that's a detailed discussion. These are the detailed areas which will be kind of discussed in the, you know, basically a class part. Okay, now coming to big data TDD using big unit. So guys, before I even proceed on any part, first of all, I'll just quickly tell you about you know, what exactly is the test driven development. Okay, so, or TDD. So TDD actually stands for test driven development itself. And what does it typically mean? So again, rather than reading all of the stuff, because I think I have to do a bit of hands-on also to you people. So all I would just say is typically your development cycle is you typically write the code and then you typically write the test cases to see whether your code is working fine or not, and then you kind of make sure that yes, you are actually producing the output whatever you are supposed to. But in this way, the idea is to write the tests first, not really the code first. And that's why we call this as red-green refactor cycle. So first, what happens is in the test-driven development, you first write a test case. Now you don't even have the code. So what will happen? When you will run the test, it is going to fail, right? Then you write only enough code to pass that test. So that first stage was the red, wherein you had the failure. Then second stage was wherein you wrote the code and then your test actually passed. That is called the green cycle. Okay. Last is refactor. So now again the same thing will happen. You will write a second test case. You will write another only code which is just going to pass these two test cases together. And then this cycle keeps on going till the time you complete the requirement. Okay. So this entire cycle, in that process you might like to refactor some of your code, you might have written some extra code and other stuff. So this cycle is called red-green refactor cycle, and basically it follows that same paradigm of extreme programming itself, wherein we are saying that your test is going to be written before the code itself. The good thing is you will always have the 100% code coverage, because your code is written only to pass the test. So there your typical way of unnecessary code and other stuff, those things are gone automatically. Okay, if those things are gone, then why is world not following the TDE, right? Why is world not even going towards, or most of the companies don't really follow the test-driven development? Because I'll give you very honest answer. Simple thing is procrastination. That's it. Okay. So these are some of the very popular kind of reasons. I cannot follow the test-driven development, guys, because understand, my code is working. Let's freeze it for now. Let's just freeze it for now. Okay. And or for example, my release date for our project is just approaching. It is very aggressive. I cannot really follow the test-driven development, that first I write the test case, then I write the code, and then again follow it. It's gonna take forever. So I'm not going to follow it. Or your development cycle is going to be reduced, or you might be having less number of people, or if the developers themselves are writing the test cases, then what are testers going to do, right? So all of these, and there are plenty other reasons which are typically given by the different teams for not following the test-driven development. Basically, they follow the case wherein they first write the code, then do the test cases and things like that. It typically leads towards a thing called technical debt. So over the period of time, right, over the period of time, you keep on increasing the technical depth of your project altogether. So you keep on adding more and more code which is kind of untested. And this is something which I would love to show you. This is not told by us. The most powerful force in the universe is actually your compound interest. Oh, and just to explain this, again, these are some of the quick slides. For the experienced guys, it should not come as a surprise, right? So you have a bug, you identify it at the design time, your effort is somewhere this much. You find it at the implementation time, it increases. Find it at the QA time, okay, but post-release, if the client has found, this is what the effort would be. Of course, because post-release, if you find it out, then again you will go through all the cycle of design to implementation to QA and post-release, right? So again, this is not a surprise, but yes, these are some of the industry level figures altogether in terms of unit, right? So your traditional development is typically this way. You design something, so you design means you create kind of algorithms and other stuff, you kind of create your implementation strategies, and then you implement. You actually write the code for it, and then typically you go for the testing of your code, right? Whereas when it comes to a test-driven development, every phase, first you have to write the test, Okay, first you just design it, then you are going to write the test, then implement, then again test, then implement, and typically your cycle would look like something like this. Okay, so design, that's fine. Then write first the test, test, implement, and this is how your cycle keeps on going. That's where you go for the test-driven development part. Okay, so again, I know that many of you would be aware of test-driven development. The idea was just for those people who would have never heard about this kind of, so it's a different paradigm, as I say, of the development practices itself. It's not your typical waterfall kind of a model. Typically, these kind of models are, followed in the agile teams and other stuff, wherein they follow so like in my team, okay? So whenever there is a failure, I never ask for the code. I ask for the test cases. And if the test cases are good, then we don't even take any blame. But if test cases are not good, then it's a problem for the team. That's how it goes. Right, guys? I hope you are just getting the understanding of it. Right? With this, can I just proceed forward to the last part? Without writing code, what will we test? Are you talking about the testing of the algorithms only? If yes, then how is it possible? No, Prince. You know that this is the requirement. Then what are the test cases? Test cases are typically prepared by the testers, right? So what we are saying is write your test cases first, and then don't have the program. Let the things to fail. Okay, let the things to fail, and then you write only enough code to pass that test. So first you wrote a JUnit test. Okay. Yes. So TDD is very good for the agile project. Exactly, Saurabh. Prince, got it right? So the advantage which you got is you didn't write the code. You wrote only the code to pass the test. And in this case, if you followed it, then remember when you completed your requirement, you had only enough code which is sufficing your requirement and nothing else. Right? So Vignesh and others, yes, I'm just going to give you a very quick example of it. Again, not really possible for me to go into the depth of the code right now. We are left with some 3-4 minutes, but I would still like to give you an idea, because this is something which we'll be covering, when we'll be covering PEG in the actual classes also. Okay, so without code, how come testing will happen? Exactly, Ravi. Let us just hold on. I am going to take you to the screen altogether. Okay, in the machine I'll show you what exactly do we mean by that. Okay, so in PEG you can perform the unit testing using something called PEG unit. Okay, and typically again some of this part might not be very clear to you people. It is just about that PEG is actually not a programming language. Typically people say, since it's not a programming language, it is just a data flow language, why are you using PEG? Why are you even testing it? Because you are ultimately just writing a data flow and you are not writing any program. So why to bother about doing the unit testing? But again guys, these are again just the examples wherein I would say it will lead to the technical depth and nothing else. Okay, so without wasting further time, I'll just quickly introduce you to something called PEG unit. Okay, so PEG unit is a framework for testing the PEG scripts. Okay, it is the place wherein at the back end actually your JUnit tests are going to be run, but the idea is you are going to test the PEG scripts themselves, and typically those PEG scripts, as you saw that they are the wrappers on the MapReduce, typically they run on the HDFS. But you would not really like to test your programs using huge amount of data. So you can kind of mock some amount of data. You can supply your data by yourself and then set the expectation and things like that without even persisting the data into HDFS. Okay. So basically, as you can see that your store statements, basically all of your store statements and other things are kind of short-circuited using PEG unit. Okay, so before actually I come to this slide, guys, we'll be overrunning by 10 minutes. Is that fine with everybody? Right? I'm just trying to show you, a quick amount of a small code. Okay. Again, I'm not really going to do a code walkthrough. What I'm trying to achieve here is, from the schematic perspective, I'll just show you if I had to, because right now I'm in a demo, so I cannot really start it from test and all, but I'll tell you if I had to do the test-driven development, how would I have done in this setup. Okay, that's the only idea. And in the actual classes, we'll actually be focusing on that part. Okay, so this is my virtual machine wherein I keep creating a lot of code and other stuff. So guys, this is right now a pig script, which, and by the way, I'm in a full screen mode, so I might not be seeing your comments and other stuff for now. Okay, so this is my pig script, in which right now just ignore this. Basically, this is about some sort memory. I'm just setting it up here, but for all practical purposes, from the logical perspective, just see what I'm trying to achieve. I'm loading an input file, okay, using pig storage. For now, just assume that it's a class, and then this is the kind of schema of the data. Okay, by the way, how is my data looking? Data looks like something like this. So first field is the roll number, second field is the subject, third field is the marks which are secured in the subject. So roll number 1, subject English, marks 40. Roll number 1, subject science, marks 45. Roll number 1, subject mathematics, marks 50, and so on and so forth. Right? And then in the pig script, I'm first loading this data in this stage. Then I am just considering the roll number and the marks only. I'm ignoring the subject, and then I'm kind of grouping it based on the roll number. So this is group formatted by roll number. Okay, so I'm basically grouping it by the roll number, and at the end of the day, I'm just finding out the roll number wise average marks. So AVG is average. I'm sure that some of these operators would be new, but from the schematic perspective, I hope it should be quite clear to you. At the end of the day, I'm doing a group by average operation wherein my key is roll number. Is that just clear to everybody what I'm trying to achieve here? Right? Guys, Ravi, others, Surbi, friends, everybody, right? So the gist is, I'm loading a file which is having 3 columns. I'm considering only the roll number and the marks here, and then at the end of the day, I'm doing a group by roll number and taking the average of marks, right? This is a very simple kind of an operation which I intended to achieve. Okay. Now there is this Eclipse. Oh, okay. So before the class, I actually make sure that all of my code is running. So I ran that code all together. Guys, for now, please ignore like, what mock pig feed is, what mock input alias as, etc., etc. These are obviously some of the Java functions and other stuff. From the flow perspective, what I'm doing is, I can say that what exactly is the script which I'm trying to test. So you can see that it is testable script.pig, and that exactly is this testable underscore script.pig. Okay, so this is the script which I am kind of trying to test here. So testable script.pig, and then you are talking about, see this, you can easily understand that it's a Java program, so it can be a parameterized thing as well. And then I can always define what can be my input file. So I can say this is my input file, or I can even define my inputs here. So I can say, assuming that this is my input, 1 English 40, 1 science 45, 1 mathematics 50, the output which I expect is 1,45.0. And then this is where I kind of say that, assuming that your input, which is marks file, okay, go back, see this, marks file was your original input, right? So in the code I'm saying marks file is equal to whatever I'm supplying, the output should be this, right? Guys, schematic perspective, is that part clear to you? What I am trying to achieve in the J unit test, or basically pig unit test case, right? Is this the TDD? It is. It is the part of tests. So test-driven development. I'll come to that, Ravi. I think you have asked this question, so I'll come back to this question. Don't worry. I'll answer that before we end it. Okay. So is this part clear that it's actually a test which I wrote? Right, guys? Could you please confirm about this part? Right, so it's a simple test wherein I'm just trying to solve a thing. Now, right now, you have the pig script also written, you have the test case also written. Ideally, so Ravi, now I will give the answer of your question, right? So, what I'm just trying to tell you is, if it would be a test-driven development, if it would be TDD, I would first be writing these test cases first. I would be saying, this is my first test case. I will say, if my input is this, if my output is this, the output, basically, if my input is this, I'm expecting this kind of output. Is that clear? Without even first writing the pig script. Is that clear? That question was specifically from Ravi. Ravi, is that part clear to you? If I would be doing a test-driven development, first, right now I know what exactly I want to achieve. So I know, given that this is the input, this is my expected output, right? Without even writing the pig script. At least this much I can write, right? Ravi, others, could you please confirm? Right? And what would happen? If you would write your test case now and you try to run it, it is going to fail because you would not be having any pig script. Then you would write some of the pig script and then you will let it pass. Okay, that's how it would happen. But right now, instead of giving you all the success, let me just generate some of the failures also. Okay, so instead of 45.0, right now all of that was a success. Let me say 45.1. Okay, and then just go and say run as JUnit test. You will see that it's gonna run. So it just basically loads everything. So see this, one test is passed, green means it is passed. See this, first test has failed. Okay, you can see that here. And then the second test has passed. If you click, see this, expected 45.1, but actual result was 45.0. So I purposefully made it fail, right? I'll go back and I'll change my data again. My expectation should be correct. So I'll go back and I will say 45.0 and then run it. Now if I run it, okay. So by the time it completes, Ravindra has asked a question, what is the difference between JUnit testing and pig unit testing? Nothing. With pig unit, you are testing the pig script rather than a Java program. And it is, at the end of the day, it is a wrapper on the JUnit. Ravindra, clear? So the question, which was asked some time back, Ravi, I hope your question is also clear, Ravi Tiwari. So guys, see this, all of that in the meantime got, see this, all of 3 got successful. Okay, so this was a very small demo in that I didn't even show you, the actual code and other stuff because that was not really the focus. I can easily, you can easily understand, of course, these things for them, we are actually having the dedicated sessions and the classes anyway. Okay, so what is the main purpose of pig unit? The main purpose of pig unit is to test your pig scripts. Okay, now Siva, And I think this was a question from others as well. So I hope you are just getting the idea of test-driven development. Now let me just quickly come back. So guys, these are some of the job trends. Again, these are some of the things which are from the Indeed.com. It is not from Skillspeed. I don't really need to talk much about it. That's fine. Uh, some of the course curriculum. So now these are some of the last things which are not really related to the any of the concepts, but this is about the kind of upcoming batches and the things which we plan to cover in the course itself. Okay, so we have divided the overall course in kind of 5 weeks. The first week typically talks about the basics, right? So as you can see right now, we talked about big data, Hadoop, HDFS, etc. within 1 hour. But if you see first week, 2 classes is actually 6 hours. We are going to talk about introduction to big data and Hadoop, different Hadoop configurations, different data loading techniques, etc., etc. Second week is only dedicated to MapReduce. Okay, this is the week nobody can afford to miss, wherein we actually talk about what exactly a MapReduce paradigm is, how exactly you can create the programs in it, then how exactly can you apply the advanced concepts. Okay, the third week focuses more about PEG and introduction to Hive. So again, third and fourth week basically it talks about PEG and Hive, and basically for the people who are non-Java users and still want to use Hadoop. Fourth week we start HBase introduction, but then the fourth and then the fifth week typically goes into HBase and Uzi workflow creator altogether. And then last class is something which is fun, wherein we don't really learn anything. When I say don't learn anything, we don't learn any new concept. That is where we typically focus more about a project setup discussion, and that project setup discussion, as if it is happening, let's say within your company, a specific project is being incepted, right? So how do you really start from zero? Proper project discussions, not by me, by you people. Okay, so that's one of the interesting things which we have seen from people. People typically like it. So this would be one. An interesting thing about the people, if you feel that yes, it is interesting thing, then in fact for the people, we have even given a kind of a free trial of Hadoop and Big Data course. So it's kind of a, you have 3+ hours of training material which will be available, and access to the assignments and quizzes also, and at the same time real classroom experience. So even though the classes would be online, but you can even see some of the recordings of the classes. You will even find it in the classes as well. They are going to be quite interactive. Like right now I'm trying to answer as much questions as possible, but again, since people are so many, so within 1 hour, of course, a limited kind of questions could be answered. But there we have much kind of a concentrated batches, and they are going to be quite interactive, not only from the typing perspective. Even sometimes when the doubts are not really clear, we typically ask people to come online, and then we typically talk as if we are in a real classroom altogether. And then after that, see, when you're learning some of the things, you typically have those doubts and other stuff. So for that, of course, there are personal counseling sessions as well, which are available along with the free trial of it. And how exactly you can activate your free trial, it's all about, you just have to visit skillspeed.com, basically click on this particular course, and then you just need to click on the free trial, and you'll get your free trial. You'll be registered for the free trial, and then you can see the classes. You can take the decision. I think 3 hours of first class is going to be free, and then you can make your decision whether it's kind of a relevant thing for you or not, right? Last but not the least, there are some of the differentiators about Skillspeed. Again, talk about a vendor in market, you will be having several choices. Okay, the only thing which differs us from others is our basically curriculum is only by the industry experts. So you talked about test-driven development. I could have chosen a very simple topic of what is PEG, or what exactly is, let's say, is big data world, and that's it, ended it here. But the idea is we wanted to show you that, see guys, at the end of the day, when you are writing, when you're understanding Hadoop is one thing, and what you are going to put in production for your respective companies is second thing, right? So the focus is as if you are starting from zero, and then you are actually, how do you really put your programs into production? That's the kind of focus which we typically give. So again, it is focused completely from the industry perspective rather than just the concepts perspective. There would be live virtual sessions. Again, no need to talk about it. There must be many people who are just starting their career, or might just be at the early stages of the career. They might need some of the placement assistance. Yes, it is also provided. And then the 24/7 support, yes, definitely. So you have some sort of problem or something, we typically suggest. So there are helplines available, as well as email IDs are there given. And when you send an email, all of them get converted to the ticket, and then their SL is attached to it. So again, and the good thing is it is 24/7. And also the access to the learning management portal, whatever material which will be creating, either it is the audios, videos, assignments, quizzes, code examples, everything, that access is going to be lifetime. So it's not like your course is over and the access is over. It would not be like that, right? So these are some of the things, and that's what I would just say, that of course lines are open. So if these things do excite you, just visit skillspeed.com, and yes, we will definitely then meet in the class. So I just hope that this session was kind of useful for you people, with the kind of so idea was there should be some sort of takeaways out of this session, rather than, so it was not really the sales pitch kind of thing. It was all about the knowledge sharing part, and if it works out well, then yes, we can take it forward. So guys, thanks a lot for attending this session, and see you there in the classes. Okay, I'll just see if I can answer some of them. Okay, so most of the, bye guys, bye now.